All right, today with 8.7, like I said, it's a little bit different from what we've been doing this week. We are going to define a function by using equations. For our warm-up, we are going to evaluate the expressions if x equals -2. So remember, the word evaluate means that we plug in or substitute and then simplify. So we're going to plug in or substitute -2 for the x's and then simplify the expression using order of operations. These are all terms that should be familiar to us. So on the first one, I substitute in the -2 for all of the x's. I highly recommend using parentheses when you substitute so that you can see what operation you need to do. If we didn't put the parentheses here with the 3 in the middle, it might look like we're supposed to subtract, but the parentheses tell us that we're doing what operation? Multiplication. So I highly recommend using those parentheses or some separator, like brackets or a multiplication dot, something, so you know what to do. All right, we substituted. Now we simplify using order of operations. With our order of operations, P comes first. P is parentheses. Is there anything to do inside of the parentheses? Inside here, can I do anything with a -2? Or inside here? I see some people shaking their head no, which is good. There is nothing to do inside parentheses, so we go to our next operation. Who can tell me what it is? Natalie? Exponents. Do we have an exponent? Anybody see an exponent? Yes, we've got a squared. So we need to do that. The 2 out in front stays put. What is -2 squared? +4. A negative times a negative is a positive. Everything else stays the same. I kept that 4 in parentheses so that I knew what operation I was doing. What operation comes after exponents? Keon? Multiplication and division. So we do that left to right. Do we have any multiplication or division? Yes, we've got a couple of them. So we go from left to right. 2 times 4 is 8, plus 3 times -2 is -6. And then there's no more at the end there. The last operations for our order of operations, Jamal? Add and subtract. So we again do that from left to right. What is 8 plus -6? 2 plus 9 is 11. Questions on number 1? All right, on number 2. We substitute in that -2. I'm still using parentheses to help me keep it all straight. Notice that I didn't change anything about this minus. We've got a minus sign and x is now negative, so minus a negative. What do I need to do first in this problem? Keon? The exponent. What is -2 cubed? Ryan? Nope. Natalie? -8. We're multiplying -2 times -2 times -2. That would come out to be -8. Subtracting a negative means I'm really adding, so I'll go ahead and change that. -8 plus 2 is -6. All right, on the last one. We start off by substituting, and then we will simplify. Notice I've got 2 sets of parentheses. That's fine. We start on the inside. What's happening inside our parentheses? Multiplication. So since it's happening inside of the parentheses, we do that first. 3 times -2 is -6. So that got rid of one of our sets of parentheses. -6 squared is a positive 36. Remember, a negative times a negative comes out positive. All right, some of our notes for today. A function or equation can stand for large sets of data. When we graph a line, what happens? What happens when we graph a line? What is a line formed by? Ryan? We use our slope, but what do we actually write on our paper when we form a line? Carl, what do you think? What do we use to make a line when we graph a line? What do you put on your paper before you draw a straight line? What do those dots represent? So we don't usually call them dots. What do we usually call them? Points. Okay, and those points have, what 2 letters do we use for those points? Ellie? Not for the points. Deja? X and Y. Sorry, I must not have heard you. So when we graph points, we have X and Y. And when we graph a line, we have lots and lots of X's and Y's. So when we graph a line, we get a lot of XY pairs. That forms a set of data. That is considered a set of data. Those XY pairs could stand for something. We have not done a lot of word problems in this class. That comes more with Algebra II. Maybe we'll do more of that next semester, where the X's and Y's stand for something. Like X could be the temperature, and Y could be the amount of ice cream sales. Okay, they start relating actual things to each other instead of just being called X and Y. All right. Equations can be written as functions using arrow notation. It's one form of notation. So for example, this would be read aloud as P of n. So P is the function. P would represent the function. N represents the variable used in the function. The arrow sort of replaces the equals sign. Okay, so this really isn't a whole lot different from what we've seen before. Normally, we would have seen this written as something like y equals 5x minus 500. Okay, these are essentially the same thing. They are just written 2 different ways. So this looks a lot different from what we've been doing, but really it is not. They just used different letters and they wrote it in a different way. Given the certain domain of a function, you can find the members of the range. So when they throw these words out here, you've probably heard domain and range before. Does anyone know what we use to refer to the domain as? Any guesses? I bet if I tell you the domain, you'll know what the range is. Usually domain refers to the x coordinates or x values. What do you think the range refers to? The y values. Range refers to the y values. We also call this the input and the output because we don't always use x and y. So you could put or the input, and range would then be or output. By substituting a value of the domain into the equation, the corresponding value of the range is found. This is just like when we had x's and we found y's to go with them. Right, we've done this before. It is extraordinarily similar to making an XY table. Just in this case, we usually will not pick what gets plugged in. They're going to tell us what we have to plug in. All right, so we are asked to list the range of this function. They're using that arrow notation. So the function of f in terms of t is given by 4t minus 3. So all of this stuff before the arrow, we don't care about it a whole lot. What we care about is what comes after the arrow. They're listing the domain. That's what the capital D stands for, domain. So if you want to make yourself a note, that's our domain. The domain equals this set of numbers, 0, 1, 2, and 3. That's it. Those are the only things that we can plug in to the variable here. So these are what we'll plug into t. So when we do this, we plug in 0. They made this table so that you can show your work in it. So when we plug it in, we have 4 times 0 minus 3. This is why we did those warm-ups of simplifying expressions. What's going to happen first here? Multiplication. What's 4 times 0? 0. 0 minus 3 is negative 3. So negative 3 would be part of our range. All right, next let's do 1. Again, we plug it in. We multiply first. 4 times 1 minus 3 is 1. Next, so we've done the 0 and the 1. Next up is 2. We have 4 times 2 minus 3. What's 4 times 2? 8 minus 3 is 5. And last we plug in 3. What is 4 times 3? 12 minus 3 is 9. So this list that we just came up with over here, that is our range. So we should note it the right way. We use the capital R, we use the curly brackets, and we're going to list them out from smallest to biggest. Now, lucky for us, the way that they went starts smallest, goes to biggest. So we can just list them out with commas. Negative 3, 1, 5, and 9. That's it. That's how we find our range. Questions about finding range? Okay, let's do it again. What's the first thing we're going to plug in to our expression? Natalie? -7. Now you'll notice here they wrote this a little bit differently. They did not use the arrow notation. They just used kind of what we call standard function notation. But it's the same idea. This could have been written as f:(x) arrow. This could have been written as y equals, right? Like all of this stuff is the same thing, stands for the same thing. What we care about is what's on the other side of that. So it does not matter what they put on the left side. Those are all just different ways of saying this is a function. This is the variable we used. This one doesn't tell us the variable. That's fine. That's what we're most familiar with. I think that the f(x) is the most common one, especially when you get to Algebra II. But, all right, here we go. So we're plugging in -7 to this expression. 3 times -7 minus 2. Again, on this one, our first operation is going to be multiplication. 3 times -7 is -21. -21 minus 2 is -23. Very good. What's the next thing I'm going to plug in? 0. 3 times 0 minus 2. 3 times 0 is 0. 0 minus 2 is -2. What's the last thing I'm plugging in? 5. 3 times 5 minus 2. We start with the multiplication. 3 times 5 is 15 minus 2 is 13. Okay, so then we just have to list out our range. We use the capital R. We use the curly brackets. We list our numbers from least to greatest. So what's the smallest number on this list I made? -23. The next smallest is -2. The next smallest, which is really the biggest, is 13. Along with function notation is also a new way of writing questions. Okay, so they gave us a function up here. The function's name is g. The variable we're using is x. It's defined as 4x minus x squared. So remember, that's the part we care about, the part after the arrow. They said the set of all real numbers is the domain. So that means technically the domain could be any real number. Any number that we would talk about in this class is fair game. But they are asking us to find the function evaluated at certain numbers. So what this means right here, I would maybe make a note off in the margin somewhere. What this means is plug 1 into x. Okay, that's all it's telling you to do. It's saying that x should equal 1. Figure out what the function evaluates to. So when we do that, we can use the same notation that they did. G parentheses 1 equals. We are going to plug 1 into x into that expression. 4 parentheses 1 minus parentheses 1 squared. Really, everything we've been doing today is all the same stuff, just written different ways. What's the first operation we're going to have to do? The exponent, what is 1 squared? 1. 1 times 1 is 1. My next operation is to multiply. What is 4 times 1? 4. And 4 minus 1 is 3. So g of 1, or g parentheses 1, equals 3. That's our answer. Did we all get that down? Because I clearly need to erase it in order to keep going. Okay, let's try another one. On number 4, what am I plugging into x? A -1. So this equals 4 times -1 minus -1 squared. Again, the first thing I need to do is my exponent. What is -1 squared? +1. Negative times a negative comes out positive. 4 times -1. Nope. -4. We're multiplying. Right here, these parentheses mean I'm multiplying. 4 times -1 is -4. Then we have -4 minus 1 is -5. So that means that g evaluated at -1 equals -5. All right, let's do the last one. What am I plugging in for x? 2. Again, my exponent comes first. What's 2 squared? 4. 4 times 2. And 8 minus 4 is 4. So our function g evaluated at 2 equals 4. You can still kind of think of these as xy pairs. Like, we plug this in for x. This is what we got out. We didn't really call it y, but it's kind of the same idea. Plug in a -1, you get out a -5. Plug in a +2, get out a +4. These are like those input-output tables that you probably saw in middle school or junior high when you first started doing functions, even if they didn't call them that. Questions about these before we do our last little note? Okay. The last note. If a function is defined by an equation, the domain of the function must also be given. So we should be told if the domain is a specific set of numbers or if it's all real numbers. The domain should also be given.